Okay, so everyone can hear me? Yeah, cool. So yeah, sorry for being late, and also sorry, I'm also somewhat unprepared for this because yeah, I got a bit mixed up in a number of things, not just Dropbox problems. But the idea was, well, and also I guess most of you know that this is very likely my last time doing a ds-incubator, so I thought it'd be fun to do one last one. And I wanted to share with you a package that I recently looked at, and I haven't, to be honestly, started using it much. I don't know much about it, but I thought it was interesting, and that's why I wanted to do this, because I thought like preparing the ds-incubator would be like a good experiment for me in terms of learning how to use this package. But unfortunately, I didn't really have as much time as I thought I would. But I still think it's an interesting topic, so I want to like present to you like why I'm interested in this package and how we might be able to use it. And I'll show you at least some of the examples that the package itself provided, and maybe this will be something that we can also talk about. And I'd also be interested to maybe have a discussion about if any of you are doing this in another way or any way at all, or if you think it would be useful. So with that, yeah, so I want to start off with talking about this fail fast philosophy, which is something that's used in a lot of system designs, not only in software development, but in software development specifically for us. What it means is that you want to, when you're designing something, you want it to like error out really early on. So, and you wanted to do this because, well, you usually want to do this because often it's expensive to let a long process run, either in like time or resources or computing power or whatever. So a lot of times people design their programs or functions or whatever to check in the beginning for errors or problems that might occur later on, and then cause the error to happen really early on in the process. And then you save that time or save those resources, and you can go back and fix the problem instead of letting a long process go through and yeah, waste all your time. So some of you might already be used to this, particularly in using functions. I think it's one of the most common places I see this happen. When you have a function, one of the things, or some good advice that you'll hear in a lot of places, is that you should check first the parameters, make sure that the parameters are legitimate, and then fail before the function tries to do anything, and let the user know that something happened or that the parameters that they sent were not correct. So that's one use of fail fast, one that I'm semi-familiar with. But something I'm not so familiar with is like integrating this into like an analysis process. So a lot of us have code where we're not writing a function, but we have these huge data processing kind of chains or processes that we go through. So we read in some data, then we're changing it, we're filtering some of it, we're adding new columns, etc. And ultimately we're preparing that to do something later on, whether it's like passing it to a ggplot, or in my case for the past few months, passing it on to JavaScript. But when we're doing that, we have some expectations, and we can potentially know that there's going to be something wrong, and we could check for that beforehand. But that's not something that I commonly do, but I realize maybe I should be doing, and maybe some of us should be doing that more commonly in the process we're doing. So that's the basis behind this. I did start writing a little bit of an example, which I can kind of talk through on my screen. So here I'm just loading in some data. This is like actually real stuff that I've been working on the past 2 days or a few days. And if, for those of you that remember, if any of you remember life before like tidyverse, this is how we were often like loading in. So imagine I loaded in this emissions data, and then I wanted to filter by a specific investor. So I would do that, and then I'd save it as DF or something. And then the next step, I want to filter by the portfolio name. So I do that and then save it over top of itself. And this, like, at least for me years ago, was like fairly typical process. And I think probably all of us agree this nowadays seems extremely archaic and not so nice. But one of the things that is kind of nice about this process is that at any point in this process, I kind of have the full data set as it is from that after I've done all those processes. And it could be very easy for me at this point to add a new line and say, oh, I want to make sure that that none of df asset type is yeah, so I could say like, make sure that all of these things are not. And then I could also put this in a stop if not, or something like that, if I wanted to cause an error. But in my impression, like this is like a bit easier to do outside of a dplyr chain, because you always kind of have a nice breaking point. So you could do this with it. So here's this same process in a dplyr chain. It does the same thing. And you could maybe, for instance, start breaking things up. Like if you realize halfway through this, you wanted to do that, and then we could like break this chain up and then save it as something else and then start the chain over and then put our test in here. So you could do this, but I think that's a bit tedious. And also then you start creating all these new intermediate objects, which is one of the kind of benefits of using a dplyr chain. So this is all leading to, I found or became aware of this package, which is in my browser somewhere. And let me bring it up here. So you can see my browser now, everyone? Yeah, okay. So there's this package that our OpenSci made called assert R. And what it does is it creates these like assert commands, which you can insert directly into a dplyr chain. And this allows you to do some of those testings like within the dplyr chain without leaving it, but doing it in the middle and still then even continuing on later on with the rest of your analysis. And I think this is a pretty interesting idea, and I think I was particularly interested because it fits into like our sort of dplyr world. So this is something that I want to start trying to integrate into my own code, and I thought it's something worth discussing with you guys about maybe how you feel about that. So we can test this out a little bit with our example here and show you what it does. So they're just using the empty cars built-in data set. And all of these things in the beginning are assertions that they're making. And we could say that, like in this case, they all pass. So it just moves through. But if we, let's say, if we told it, well, we want to make sure that it has another name, like, yeah, something for sure is going to fail. And if you do this chain now, it stops very early on. So this is this concept of failing early. I start with this data set. I know I want to like do some grouping and some summarizing at the end, but like before I do that and before like I get further down in this process and something goes wrong, I want to test and make sure. So if I know that like this column name, that's obviously ridiculous, but like if I know that I'm going to need this column XXX and I put this in an assertion in the beginning, then when I run this command, it fails right there. It doesn't go through the rest of this process. And it also gives you like some fairly nice error message. So it's easy to figure out what's going on. And each one of these are different types of assertions. They have a few of them. Yeah, again, like honestly, I didn't really have enough time to go over them enough for me to tell you everything about them. So if you were interested in it, I would suggest like looking at this package and reading through its documentation. It gives some on this main page, it gives you some pretty good information about what each one of these are and what they can do. And yeah, so I don't have a whole lot more to say about it. So I think that maybe we could just have a discussion about it. I'd be interested if anyone else has used this package or used an alternate path to doing this, or if people think this is a total waste of time, or if they think this is something they could use or have seen purposes for. So yeah, I open it up for questions, comments.
I think it's cool.
So I guess I'll throw a question in here. Is this something that you think is useful as we are developing our code and then we take it out of it, you know, sort of as we move towards production? Or is this something that should be like once things are in production, there are still these assertions baked in there that define what our data should look like?
Yeah, so my response to that would be, in some ways, like I see the production side as much more kind of critical, because if you really want things to work well and you want lots of, like, all of us on the team or multiple people on the team to be able to use it and things not go wrong, then like the production side is like the more obvious place for this. But that being said, at least for me in my sort of development process, that's usually where the most stuff goes wrong, because you're still figuring things out, you're still working through stuff. And like some of the stuff that I've been working on for the past few months, sometimes it takes, you know, more than a minute and a half to run through an entire process. And if I had some things checking, doing some like real obvious testing in the beginning, maybe that I wouldn't have wasted that time so many times waiting for it to run and be like, oh, the whole thing failed, it didn't work at all. So I can definitely see some value for this early on in the process too, because for me, that seems to be the time where I'm wasting the most time in terms of running a long process that ultimately fails. Vincent had a comment.
I was just to finish up. I mean, I'm working on the fun code right now, and I'm doing something similar, but it's not as like just easy and not as in the workflow. Like I have an if-else statement surrounding, you know, if it meets its condition, it will run. But
Yeah.
like, I think this is much like I just like how seamless it is.
Yeah.
And it achieves the same result. And I think once I'm familiar, like I'm already excited because I am playing with it already. So thanks.
Yeah, that's a good point. Like a lot of code ends up having these like nasty, long, just really ugly if-else statements that go on forever, and many, yeah. And then, you know, if-else statements they depend on these curly braces, which makes them rather more sensitive than, you know, other sort of lines of code, because they sometimes span multiple lines, which means they're easy to end up causing bugs and stuff like this. So yeah, I hadn't even really thought of that, but yeah, that's one way that people end up doing this. And you know, maybe this is a suggestion for a different way to do it. Yeah.
CJ, could you please show a case where the package throws an error and then you follow that with a call to trace back? I think that could be useful because by design, the package seems to not show where the problem is coming from, which is a design principle used a lot in the tidyverse, because, you know, then it assumes that the user will call traceback, but traceback is a function that is not so well known. So I would like to show, you know, how with traceback you can have insight about where in a long change specifically the error comes from.
Yeah, I don't. So this particular package doesn't provide a traceback. So you can see my RStudio now.
Yes.
So like this is the result of what happens when assert R captures a failure. or an error. And what it does is it gives you this result, and it's actually kind of cool, but it's very targeted towards being inside of a chain. So it tells you like exactly what failed. It will tell you the column and index value where it failed. And if it fails in multiple places, like it will give you like multiple lines, and it will tell you exactly which, you can basically work back and figure out which column and which row, like what are the actual locations of the data points that failed that test, which I think is pretty nice. But I like what you're saying. I could maybe force this trace
That's
back.
okay. Actually, I didn't. It was my mistake. I didn't notice actually that it was some text output there. I just focused on the error message and didn't see anything below, but there is stuff on top. So I think that the package does well what I was trying to achieve with traceback. So I don't think this is there is a need for it.
I mean, maybe do something like.
I mean, could you like to try to run the function traceback already on the console, because the last error message should already be kind of on the list. Yeah, so I think that if you run traceback, you should get some output there. Yeah. Yeah, there you go. So 8 is coming from 8. So so in reading 8 is where I could normally understand what's going wrong, but I was wrong myself in asking the question because I didn't notice that the package itself gives you even a more informative output than what I read in line 8 of the traceback.
Yeah. So it's it's a bit wonky because in some ways it's kind of not an error because it's doing what it's intended to do. It's stopping the function at that point. So that's why this is not showing a normal traceback. But maybe if I just made a crazy mutate command, and this is kind of what would happen if you had a problem in your dplyr chain, and then I mean I've never actually used this rlang last error, but this is what they're telling me to do, so I can see what that does. Yeah, so it's kind of a specially formatted backtrace. But yeah, I think what this package is doing, like the kind of results that it gives you for the error, is a bit more informative than like the standard traceback, or even this this rlang's error message. I think this is a bit more, yeah. It's kind of along the same lines of test that and the assertions in that. So if you're familiar with that, I think this would be along the same lines.
That's very cool. I pasted a link to a design principle of the tidyverse that could help people like Vincent who are already writing their own assertions to explain how you can create custom assertions that are pipeable. Basically, all you need to do is, if you are building an assertion or a not a stop, but a warning or a message or whatever, that is what is called a side effect. So you call that function because of the side effect of, for example, throwing a warning, as opposed to a computation that you want to do on your data. So the design principle goes as follows. So if your function is called mainly for its side effects, it should return the first argument invisible. So if you do that, what you end up with is with a function that is pipeable, meaning that your function will return the warning, but also on the console, but will print the warning on the console or the error on the console, but will also try to return invisible the data, which means that the data can flow through the pipeline from the beginning to the end, no matter how many times you have warnings or messages or any side effect like writing a file to a disk in the middle.
Yeah, I've used this before also. One thing that I liked about this package is the assertions are a bit more complicated, and this is what I would have liked to be able to give you more specific examples of this and explain this more in detail. But like, for instance, the verify is a sort of assertion of like some characteristics of the data frame. Then they also have these like row-based assertions. And these are kind of like doing a combination of doing a row wise inside of it and then like being able to test per row. So yeah, when I was reading through the examples and reading through the documentation, it seems pretty flexible, and some of the ideas that they have of what kind of assertions you can make get like rather complicated, and I feel like I'd rather use this than make this pre-rolled or make my own DIY version of these like side change things. I mean, yeah, it is totally possible, but some of what they offer here seems like it would be rather complicated to do on my own.
Thanks, CJ. We have a couple of minutes, and maybe there's people with questions, but I would like to spend at least 1 minute acknowledging your enormous contribution to Data Science Incubator. A lot of the times you may have heard me speaking, but CJ was always on the background. The very first time he joined the organization, we met and we had a conversation about things that we have noticed in the organization that we could do our little contribution to kind of help people come up to the best practices that we know about. So this is just to my personal acknowledgement to the huge impact that sometimes was not visible, but it was always there. And also CJ has always been a person who had the confidence because he knows his shit, but also because he's very good at kind of talking to people. He had the confidence to tell me that I was saying bullshit sometimes, so but always in a very polite way, and that's something that I need, because otherwise, if people just say yeah and are too polite, then you sometimes don't have like a good reference to recalibrate your path. So from my end, like a big applause to CJ. Thank you very much, CJ, for your contribution here. So if anyone else wants to say thank you before we finish today.
Thank you, CJ.
Thank you. Thanks, Mara. Cool. Yeah, this has been fun. Yeah, I guess a lot of like, one of the reasons I've been kind of unhappy is because I've been doing so much JavaScript and I don't really like it, and I do like R. So this specifically ds-incubator has been like a relief for me to some degree, because I get to dive into R again, and it's fun. So yeah, happy to be involved with it.
I'll miss you, CJ. Thank you very much.
All right, thanks guys. Ciao.
Thanks, CJ.
Thanks, CJ.
And good.
So now when I end, this will stop. All right.